Hey guys, here's a question. How many water molecules are in a single drop of water? So we have Mr. Ant here, and he's rolling a single drop of water. And the question is, how many molecules of water would be in that one drop? Any ideas? I'm sure you just said a lot. Yeah, there are a lot. There are, a 1, a 5 here, and then lots of zeros and commas, right? It's a big, big, big number. There are that many molecules. Here's your second question. What is the mass in grams for a single atom of gold? So I'm not talking about this whole brick of gold here. I'm talking about one atom in that brick of gold. What would be the mass for that atom in grams? You're probably thinking something very, very small, and you'd be right. So again, we have lots of zeros. We have a decimal out in front this time, and then a 327G, G for grams, right? Okay, so great. Here, what is one more final question? Can you perform the following calculation in your head? So we have 4,500,000,000 times 0.000734. I bet you're struggling to do that in your head, and you're probably reaching for the calculator. So really, what am I trying to get at here? Well, why is what we're talking about important? What are these questions really getting at? In science, we're going to deal with very large numbers and very tiny numbers all the time because we talk about small stuff. So you need a lot of that small stuff. It gives you a large number, and that small stuff itself has a very, very small number to represent usually its quantities or size. In the multiple choice section of the AP exam, you're going to be asked to do calculations with numbers like you see above here, and you're going to have to do it mentally because you can't use a calculator on the multiple choice portion. So I'm going to show you some tricks, a way for you to think about that. That will make it a lot easier. It has something to do with this thing called scientific notation. So here we go. We are most familiar with numbers in something called fixed notation. That's your typical number, like 123.0 right up here, or 0.024. Okay, that's a typical number we're used to looking at. In chemistry, we will often work with numbers in scientific notation. So that's this right here, the 6.02 times 10 to the 23rd. Avogadro's number, the mole, what we learned last year. So let's break it down and talk about the parts of that scientific notation. There's the sign, okay, out in front. It can be negative, it could be positive. For almost all of our purposes, it will be positive. I'm struggling to think of a situation right now where it will be negative, so don't worry about that too much. It will almost always be positive. The significand is the part in front here where we actually have digits. So it's always going to have one number in front of a decimal. And that number could be a 0 or 9, any of those digits. And then it could have at least 1 or 2 or 3 or 4 multiple numbers after the decimal. And then finally, there's the exponent. So it's always going to come with this times 10 or base 10. And then the exponent could be either positive or negative. So this is where paying attention to sign is important, whether that exponent is positive or negative. So let's practice a little bit. How do we change a number from fixed notation to scientific notation? And I've kind of given you some steps to do that here. So step one, we're going to move the decimal to the left or right so that there is only one non-zero, a 1 through 9, to the left of the decimal. So given this example of 6,400, I have my decimal here. I need to move it to the left or right. This time I'm going to move it to the left so that I can get one non-zero, which is going to be the 6 here, in front of the decimal. So now my decimal is going to be right there. All right? So that's step one. Awesome. So now I get 6.4000. Step two, I'm going to count the number of decimal movements. And you probably do this, you already did it anyways in that first step. But let's just do it again. 1, 2, 3 movements. Okay, so I had 3 decimal movements. In which direction did I go now? I went left, right? So I'm going to add my times 10 to give me my base for the scientific notation here. One more time, I'm just going to do those movements. 1, 2, 3 movements left. Here's my new decimal. And now when I add this times 10, I add a little 3 raised up because I made 3 movements. Now if you paid attention to the beginning and you looked at that number 6,400, that's bigger than 10, right? So anytime the number is larger than 10, our exponent is going to be positive. So positive 3 in this case. If our number was less than 1, we're going to have a negative exponent. So that's one way of remembering whether your exponent is positive or negative. A second way is remembering the direction that you move for the decimal, left or right. So you can remember that moving the decimal left, that's ugly, moving the decimal left requires a positive exponent. Let's do a different color here. Moving the decimal right requires a negative exponent. Okay, so here, give it a shot. Convert 0.0034 to scientific notation. Alright, so here we go. We're going to move that decimal 1, 2, 3, 4 times here now to put that decimal right in front of the 3, or right after the 3. So I'm going to do 3.4. And I'm going to say, alright, it's times 10, because it's always times 10. And then I'm going to ask myself, how many movements? It was 1, 2, 3, 4 movements. I went right, so this time it's going to be negative, because when I move right, I have a negative exponent, and it's negative 4. And sure enough, that's the right answer. We can do the opposite as well. We can change scientific notation into fixed notation. So we can look at these numbers and go back and forth. It's good to be able to do both. So let's here change our scientific notation into fixed. All right. So I say, here's my scientific notation. I see that the exponent is negative, right? So if I remember correctly, that means that the number was less than 1. So I'm going to move this decimal to the left. 1, 2, 3 times. I'm going to put my decimal there. And then anywhere there are these gaps, I'm going to put zeros in there. 1 and 2. Okay? So here I get 0.0083. So give it a shot yourself right now. Try this one. This time you have a positive exponent, so pay attention to that. Alright, so positive 5 means I'm going to move that decimal to the right to get a positive large number. So 5 movements is going to give me 1.92. And then I move it 1, 2, 3, 4, 5. Decimal place. And put in my zeros. So I should have the number of 192,000. Hopefully you got the same thing. Okay, so a couple things to remember in case you forgot this in math. A couple special situations or considerations. Having an exponent of 0, okay? If you have something times 10 to the 0 power, that's like saying times 1. 10 to the 0 equals 1, so this would be 3.2 times 1, giving me 3.2. So you can pretty much just ignore the scientific notation, the times 10 part, when you have an exponent of 0. When fixed numbers don't have a decimal written, so 123, we're going to make the assumption that the decimal, always comes after the final digit. So in this case, it would be 1, 2, 3, point, and then we can put a 0 in there. Okay. So just make sure you're clear on that. If you ever see a fixed number without a decimal, put it after the last digit. Alright, finally, we're going to talk about some math, some multiplication and division with scientific notation, because that's really what we're going to be focusing on and doing a lot of this year. So, a couple rules. We'll start with multiplication. Keep in mind, whenever you're multiplying and dividing with scientific notation, do it kind of in 2 steps. Deal with the exponents first. Deal with them. So here's the multiplication rule. We're going to add the exponents together. So I'm just going to focus at first on my exponents here. I have 2.0 times 10 to the second multiplied by 1.0 times 10 to the third. I'm going to focus on that 2 there and that 3 there. It says I add exponents together when I'm multiplying. So I then have times 10 to the 2 plus 3. I'm going to add that 2 and 3. And I get times 10 to the fifth. So I dealt with my exponents. They're done with. Now I'm going to focus on the significance. 2.0, I still have to do whatever the mathematical operation is, which is multiplication in this case. So it's 2 times 1, which gives me 2.0. So altogether, 2.0 times 10 to the fifth. Okay, guys? Division. So if we're going to divide numbers with scientific notation, here we subtract, okay, that minus sign for the exponents. So again, I'm going to do it in 2 steps. I'm going to deal with exponents first. I have negative 3 subtracting 6, because those are my 2 exponents, which gives me times 10 to the minus 9th. And then I'm going to take my 6 and divide it by 2 to give me 3.0. So overall, it's 3.0 times 10 to the minus 9th. I'll give you a moment here. Try this one and see how you do with it, and then we'll talk about the answer. Okay, so doing this one, make sure you pay attention to order of operations. You're going to focus on this denominator first and simplify this, and then you'll do the division once that's handled. So it's a multiplication of exponent or scientific notation first. So what do? What's the rule again for multiplication? I add the exponents here. So it's going to be times 10, and then 2 plus 9, which gives me 11, right? So I know my denominator is going to have an exponent of times 10 to the 11th, and then it's 2 times 1, which is just 2, right? So I got 2.0 times 10 to the 11th on that denominator now. And then on top, so all this is going to simplify. I'm just going to put a line through it to cross it out. I have 8.0 times 10 to the 5th. So remember, when I divide scientific notation, it's going to be subtraction that I deal with first for the exponents. So 5 minus 11. Okay. And then I'm going to do my division of 8 by 2. And what do we get? We get 4.0 times 10 to the minus 6. 5 minus 11 gives me that negative 6, right? So, what should you have learned? Hopefully you learned how to convert numbers from fixed notation to scientific notation and back and forth, vice versa. And hopefully you learned how to perform some mental math using numbers in scientific notation. Thanks, guys.